Welcome to this explainer. Today, we're diving straight into the SASB chemical standard, and we're looking at one absolutely crucial metric, RTCH 1120A.1. We're going to radically zoom in from the massive global issue of greenhouse gases right down to the microscopic, localized air pollutants that chemical facilities are literally mandated to manage. So let's get right into it. You know, while the world rightly focuses a tremendous amount of attention on climate change and gross global Scope 1 emissions, we're talking things like carbon dioxide and methane, it's really important we stop and ask what other invisible, highly regulated molecules are pouring out of chemical refinery stacks. Chemical manufacturing is, well, it's incredibly complex. Producing over 70,000 diverse products doesn't just create greenhouse gases. It creates a whole secondary, often invisible profile of emissions that have immediate, localized impacts. Which brings us to our first section, the core four pollutants. Let me introduce you to the fearsome four. The SASB standard explicitly mandates chemical manufacturers to track NOx, SOx, VOCs, and HAPs. These typically stem from fossil fuel combustion, the stuff powering the processing units and cogeneration plants, as well as the actual feedstock processing itself. And because of the very nature of these manufacturing processes, the chemical industry is a significantly larger source of these specific emissions compared to a lot of other industrial sectors. Think about it this way. If we took a microscopic view of the air directly above a chemical plant, we wouldn't just see empty space. No way. We'd see this complex, highly reactive dance of chemical pollutants. Understanding exactly what these distinct, measurable molecules are, well, that's step one to actually managing them. First up, we have oxides of nitrogen, or NOx. Now, the SASB standard is really precise here. This includes NO and NO2, but it explicitly excludes nitrous oxide, which actually gets tracked separately as a greenhouse gas. Then we have oxides of sulfur, or SOx, which includes SO2 and SO3. Both of these are your classic heavy byproducts of fuel combustion. Next up are VOCs. The standard defines these as carbon compounds, aside from a few specific exceptions like carbon monoxide and methane, that actively participate in atmospheric photochemical reactions. Really think about that for a second. These aren't just inert particles blown away in the wind. They're actively reacting with sunlight right in our atmosphere, acting as a major driver of localized smog. Finally, the standard isolates HAPs, or hazardous air pollutants, and honestly, this is arguably the most severe category we're looking at today. The SASB standard strictly defines HAPs as pollutants that are known or suspected to cause cancer or other incredibly serious health effects like reproductive issues, birth defects, or severe adverse environmental impacts. It's serious stuff. Moving on to Section 2, risks, health and wealth. Now that we've identified what these microscopic molecules actually are, we have to look at how dealing with their severe health impacts becomes this crazy tightrope walk between the local community and the corporate balance sheet. On one side, companies face massive compliance costs, forced capital expenditures to fix outdated systems, and some really strict regulatory penalties. But on the flip side, getting ahead of this through technological improvements unlocks better operating efficiency and greatly enhanced brand value. The core takeaway here is pretty simple. Releasing these pollutants doesn't just create an environmental crisis, it translates immediately into hard financial liabilities. When a company fails to contain NOx or HAPs, they aren't just failing an environmental standard. They're actively threatening their own financial performance and operational stability over the long term. Let's look at Section 3, tracking the metric tons. To manage these immense liabilities, guessing just isn't an option. Under the SASB standard, companies are required to disclose the exact amount of each pollutant released into the atmosphere. How do they do that? By establishing a live data feed right from the stock using continuous emissions monitoring systems, or CMEs, or through rigorous mass balance formulas and engineering calculations. And the ultimate unit of accountability here is the metric ton. We just talked about these pollutants as microscopic, invisible molecules, right? But when a major chemical refinery operates 24/7, those microscopic particles aggregate to a massive physical scale. Measuring in metric tons literally forces a company to reckon with the sheer physical weight of the pollution they are responsible for managing. Which leads us to Section 4, technology and brand value. So, How do we actually get from tracking metric tons of dangerous pollutants to solving the problem on the ground? Because financial impacts scale with the magnitude of the release and prevailing regulations, the only way out is proactive investment. Step 1. Implement internal technological process improvements so you generate fewer pollutants to begin with. Step 2. Upgrade stack filtration to catch what is generated. And step 3. Watch your local brand value and operational security rise. This is exactly what the standard is ultimately trying to capture. It's the transition from a heavy industrial stack pumping out metric tons of NOx and SOx to the safety of a clean, green suburban neighborhood located maybe just a few miles downwind. Proper management turns a company from a heavy operational risk into a safe, responsible community partner. The benefits of this active management are incredibly clear, and they're all interconnected. By installing those SIEMS dashboards and investing in technological filtration upgrades, a chemical entity directly mitigates its regulatory risks, completely avoids severe noncompliance penalties, and improves its overall financial performance, all while vastly enhancing community trust. It's a real win-win. To wrap up this explainer, I want to leave you with a thought to chew on. We've spent all this time looking at microscopic molecules and local neighborhood impacts. But in our highly connected era of strict environmental standards and hyper-aware investors, how might managing the microscopic air quality at a single local facility ultimately dictate a massive chemical company's entire global brand reputation? It's a pretty clear reminder that the microscopic, especially when measured in metric tons, always shapes the macroscopic.